Okay, so this is a problem, a practice problem that shows just multiple steps and multiple parts along the path of this object in free fall. So what we're going to do is we're going to throw an object up. Okay, so if we just kind of do a quick little sketch, we're going to throw an object upwards, right, and it's going to reach a maximum height and fall down. And so we're going to say that the initial height, okay, is 100 meters. So y0 is 100 meters. So this is our 0 point. This is where y equals 0. Okay. And ultimately, we may run into this, what happens down here at the bottom. But if we look at the questions, it's going to say, part A, how long will it take in seconds to reach its maximum height? So if we do our process of writing down our knowns and unknowns and figuring out which ones we don't have, we're going to find that we know our initial velocity. It's a positive 40 meters per second. We know our acceleration. It's negative 10 meters per second squared, or you can do negative 9.81. We know at the maximum height that it is at 0 meters per second, or it's moving 0 meters per second. We're looking for time. And the one thing that we don't have is our displacement, right? We don't know what this max, or how high it goes up off the ground. In fact, if you look at part B, that's what we're looking for. Okay, so we're going to use the one equation that does not have displacement in it, which is that v equals v0 plus at, where this is going to be 0, and we're going to solve it for time. So time is going to be negative v0 over a, and we just plug in our numbers, negative 40 over negative 10. So know that this negative comes from solving. This negative comes from that it's in free fall. So it's going to take 4 seconds to get up to that point. Okay. So now we have how long it takes to get up. So if I just kind of update my the big eraser, so it just kind of took out everything here, right? So if I update my given values, now the only thing unknown here is that maximum height, or that delta y. So if I want to do part B, so there's part A, I'm going to do delta y equals v0t plus 1/2 at squared to find that the displacement up to the maximum height. But you do have to be careful because it says how far above the ground. So ultimately, we're going to have to add in this 100 meters that we're already up. So we're going to say delta y equals 40 times 4 plus 1/2 times negative 10 times 4 squared. Okay, so that's going to be 160 minus 580. So it's going to be a displacement of 80 meters. But understand, that's not our final answer because we're already 100 meters up. So that's like saying that delta. Oh, that's like saying that. Excuse me. All right, so that's just saying delta y equals y minus y0, right? And then this is what we're looking for. How far above the ground are we? So we're going to say y equals delta y plus y0. So we're going to say 80 plus 100. So our answer to part B is actually 180 meters, right? So you do have to be careful how they phrase it. Again, remember, physics, motion is relative. So we're looking for a point to which that's kind of related to. All right. And so now part C, how long will it take to come down to its original height? Okay. So remember, in physics, there's a saying: time to rise equals time to fall. So the answer to part C is going to take 4 seconds to come down, which means from where I release it, or from the time I release it till it reaches that original height, it's going to take a total of 8 seconds to come back down to that original height. So if I throw it up, right, it's going to take 4 seconds, and as it comes down, it's going to take 4 more seconds. Okay. Part D asks, what is the velocity at the original height? Well, remember, this kind of motion is symmetrical. The only thing that changes, so the value will be the same. So it's still going to be 40 meters per second, but because it's traveling now in the downward direction, your velocity will be negative. So to return back to its original height, or the velocity at its original height, it will be negative 40 meters per second. All right, part E. We're part E asks for. Let me pin up. I forgot what part E asks for. Part E says find the total time of travel, and then part F is find the velocity just before striking the ground. Okay, so what you can do for part E is you can expand out that delta y equals v0 t plus 1/2 at equation. Okay, to expand it to be very much like what we did for the displacement part, or the how high above the ground part. And so we're going to say that the final position is 0 meters, the initial position is 100 meters, so we're saying our line of reference is the ground, plus our initial velocity, which is 40, and then plus 1/2 times -5 times t squared, or sorry, jumping the gun here. This should be -10, not -5. Right now, so if I simplify, that's where our -5 comes into play. So it's -5t squared. So you remember from math, since this is a quadratic, you can use techniques. You can see the factors. You can do quadratic formula. But one thing I want to do is I want to make this 1, right? So I want to make this number 1. So I'm going to divide everything by -5. So 0 divided by -5 is 0. 100 divided by -5 is -20. Okay, this is -8t, and then this just becomes positive t squared. All right, and so this one actually does factor nicely. So what two numbers, when multiplied, right, give me -20, but add to -8? Well, it's going to be -10 and 2. And so this tells me that the two factors are where t minus 10 equals 0 and t plus 2 equals 0. And so that's t equals 10 seconds and t equals -2 seconds. Now, because this is time, we disregard the negative. So our total time would take 10 seconds. In fact, if you just focused on the part from the height down, you would find it would take 2 seconds to get down, and there's the 2 seconds. It's your answer, the second part of the answer. Okay. So now we do part F. How fast is it moving at the bottom? Right. So we're going to use our final velocity equation. So v equals v0 plus at. This is going to be the fact that it takes 10 seconds for the entire trip. Okay. So we're going to start at 40, right, because that's our initial velocity, plus -10 times 10. Okay, so -10 is acceleration. Takes 10 seconds for the entire trip. So it's going to be 40 minus 100. And so our final velocity at the ground is -60 meters per second. So does it make sense that this is a negative value? Yes, because it hits the ground moving downward. Right? So yes, it does make sense that that is a negative number. Okay? Does it make sense that this actual numerical value, the magnitude, is bigger than the initial? Yeah, because it's going to gain speed after you cross that point of once it hits that original height.